Let's look at two more problems that use the combined gas law. So we have here a sample of krypton gas occupies a volume. Okay, so that's our volume of 6.68 liters at a temperature of 64 degrees Celsius. You don't like Celsius. We're at 273 to that. Just do that right away. Do that conversion right when you see it. 337 Kelvin. And the pressure is 361 torr. Alright. If the volume of the gas is increased, so we're increasing a volume here, 8.99 liters, while the temperature is also increasing to 114 degrees Celsius. We're going to add 273 to that. $387. Kelvin. And they want to know what's the new pressure. So what will the new pressure be? So again, we're going to use P1 V1 over T1 equals P2 V2 over T2. Plug all that in and solve. Alright, so P1, 361 torr, the V1, 668 liters, P1 V1 over T1 equals P2 V2 over T2. Here we go, 387. And we want to solve for P2. So first I would multiply over here by 387 because that's on the bottom. Multiply this side over here by 387. And then I want to get rid of this 8.99, so we'll divide by 8.99. Divide by 8.99 over here. And those are my liters, so my liters are canceling. Everything's canceling here but the torr. So when and put some parentheses here so you know what to type into your calculator. You'll do 387 times 361 to 6.68, get a number, 8.99 times 3.37, get a number, and then do the top number over the bottom number. Let me work all that out. Take a second to work all that out. And we get P2 is 308.039 torr. And you're going to round to 3 sig figs. So 3 sig figs gives you just 308 torr. Alright. So take a minute, you can pause the video and you can try to work that out. There's a bunch of homework problems that look just like these. Let's try one more. So at STP, so remember what STP is. STP is standard temperature and pressure. So it's telling you your temperature is 0 degrees Celsius or 273 Kelvin. Pressure is 1 atmosphere. And the volume here, so at STP, the volume is 2.23 liters. 2.23 liters. 2.23 liters. When the pressure is increased to just a little bit, 1.05 atmospheres, and the new volume is 1.89 liters, what's the final temperature? So I have a PV and a T, a PV, and I'm looking for the other T, so I'm going to use the combined gas law again. P1 times V1 over T1 equals P2. And look, all our units are the same, right? Atmospheres, atmospheres, liters, liters. So our temperature that we're going to calculate is going to be in Kelvin. So P1 V1 over P1 V1 over T1 equals P2 V2 over T2. Now we're looking for T2. So what you could do, you could cross multiply and then divide. That's perfectly fine. So you can say 1 atmosphere times 2.23 times T2. So all I did was cross multiply over there, so I'm going to bring this guy over there. I have 1.05 times 1.89 times 273. And now I'm going to divide here. That 1 times 2.23 is just 1. I'll just bring it over just in case. So I'm going to divide by both of those. 1 here and 2.23 over there. So so I have 1.05 times 1.89 times 273 divided by 2.23. And when you work all that out, you get T2 is 265.193. Is that right? So that just becomes 265. Alright. Oh, sorry, that wasn't 265. I'm looking at the wrong problem. It ended up being 243 when you round it to the right number of sig figs. Sorry about that. 243. So go through that in your calculator and make sure you also get, it was like 242.9 and you rounded to 3 sig figs. Sorry about that. Alright, so you can use the combined gas law. This P1 V1 over T1 equals P2 V2 over T2. If you remember this, you have them all. So if T1 equals T2, ignore T, right? If they're the same thing. If T1's, so if it says temperatures being held constant, you can ignore those and you end up with Boyle's law here. Or if you have P1 V1 over T1 equals P2 V2 over T2. Now suppose they tell you that the volume is being held constant. Well, then V1 is the same as V2, and you get P over T equals P over T. So there's 3 laws you can basically get here. And then if we said P1 V1 over T1 equals P2 V2 over T2, and they say pressure is being held constant, then ignore pressure. So pressure's not changing. Or if they give you a problem and they don't have say anything about pressure, then you can have V over T equals V over T. So this is Charles' law. This is Boyle's law. When you put it all together, it's the combined gas law, and then you can also get Amundsen's law, which is just comparing pressure and temperature. We didn't derive this one, but you can get it from the combined gas law.